The current divider rule is a method used to calculate the amount of current in each branch of a junction. The general current divider rule calculates the current through the branch by multiplying the total current of the circuit by the total resistance of the circuit divided by the resistance of the branch. This equation is derived using simultaneous equations as voltage remains constant across the branches and the total circuit, giving the final equation. To show this in practice, this is an example problem which shows 15 amps approaching a junction which divides into 3 branches, each with different resistances. We are going to solve the current going through the first resistor of 6 ohms. The first step of solving this problem involves calculating the total resistance of the circuit. It is done here by finding common denominators of the different resistors, adding them together, and then finding the reciprocal, which equals 2 ohms. The next and last step involves applying the current divider rule. Through using the diagram in our calculations, we have the values of total current, total resistance, and resistance through the first resistor. This all calculated together equals 5 amps. In the background, I did some further calculations and calculated the current through the second resistor and the current through the third resistor. And using Kirchhoff's current rule, which states that all currents entering or exiting a junction will equal the same. As the total current is 15, all the currents added together also results in 15. There is a special case for the current divider rule when there are only 2 resistors in parallel branches. The current through one of the resistors is calculated by the total current multiplied through the resistance in the other resistor over both the resistors added together. This is derived in a similar way to the original equation by using Ohm's law and simultaneous equations to add the total voltage of the circuit into the equation for the current through the resistor. The special case is used due to its simplicity in calculations. The only step that is needed is to add in the values. So we have the total current, the resistance through the second resistor, as well as the resistance through the first resistor, and through plugging in the values, it results in 30 amps. Here is an example problem for the special case. It shows 120 amps entering a junction which splits into 2 branches, one with a 30 ohm resistor, the other with a 10 ohm resistor. We will calculate the current through the 30 ohm resistor. And similarly to the last example, here is a check using Kirchhoff's current rule to show that the equation is correct.